Hello students, in last class we discussed mm, in last class we discussed the Rolle's theorem and its geometrical interpretation. So this is the continuation part of that one. Yes, I just wanted to rebate what is Rolle's theorem and what it states. So the Rolle's theorem states that if f of x is a function defined in the closed interval a b such that ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಕಂಟಿನ್ಯೂಯಸ್ ಆನ್ ಎ ಬಿ. ಸೊ ಕಂಟಿನ್ಯೂಯಸ್ ಅಂದರೆ ಎಲ್ಲೂ ಬ್ರೇಕ್ ಆಗಲ್ಲ, ಫಂಕ್ಷನ್ ಎಲ್ಲೂ ಜಂಪ್ ಆಗಿರಲ್ಲ. ಸೊ ದಟ್ ಈಸ್ ದ ಕಂಡೀಷನ್, ಫಸ್ಟ್ ಕಂಡೀಷನ್. ಆ್ಯಂಡ್ ಸೆಕೆಂಡ್ ಕಂಡೀಷನ್, ಎಫ್ ಆಫ್ ಎಕ್ಸ್ ಇಸ್ ಡಿರೈವೇಬಲ್ ಆನ್ ಎ ಬಿ, ಓಪನ್ ಇಂಟರ್ವಲ್ ಎ ಬಿ. ಸೊ ವಿ ಕ್ಯಾನ್ ಡ್ರಾ ಇಟ್ ಟ್ಯಾಂಜೆಂಟ್ಸ್ at all the points. It is differentiable at all the points in between a b except a and b. Now at a and b, now it is not necessarily be differentiable. Okay, and it satisfies one more condition, that is f of a is equal to f of b. If these three conditions are satisfied by a function f of x, then definitely it exits one value c in between ab, that is the value in between ab. At that point differentiation of the function is 0. This is the Rolle's theorem. ಈ ಮೂರು ಕಂಡೀಷನ್ಸ್ನ ಯಾವ ಫಂಕ್ಷನ್ಸ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡುತ್ತೆ ಆ ಫಂಕ್ಷನ್ ಡೆಫಿನೆಟ್ಲಿ ಒಂದು ವ್ಯಾಲ್ಯೂನ ಎ ಬಿ ಮಧ್ಯದಲ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ. ಆ ಪಾಯಿಂಟಲ್ಲಿ ಫಂಕ್ಷನ್ನ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಏನಾಗಿರುತ್ತೆ, 0 ಆಗಿರುತ್ತೆ. ಸೊ ದ ಡಿಫರೆನ್ಷಿಯೇಷನ್ ಆಫ್ ದಿ ಫಂಕ್ಷನ್ ಅಟ್ ದಟ್ ಪಾಯಿಂಟ್ ಇಸ್ 0. ಒನ್ ಪಾಯಿಂಟ್ ಇದ್ದೇ ಇರುತ್ತೆ ಡೆಫಿನೆಟ್ಲಿ, ಮೂರು ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡಿದ್ರೆ. ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಪಾಯಿಂಟ್ಸ್ ಕೂಡ ಇರ್ಬೋದು, ಈ ಕಂಡೀಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡೋ ಒಂದಕ್ಕಿಂತ ಜಾಸ್ತಿ ಪಾಯಿಂಟ್ಸ್ ಕೂಡ ಸಿಗ್ಬೋದು, ಬಟ್ ಅಟ್ಲೀಸ್ಟ್ ಒಂದು ಪಾಯಿಂಟ್ ಅಂತೂ ಸಿಕ್ಕೇ ಸಿಗುತ್ತೆ ಅಂತ ಹೇಳುತ್ತೆ ರೋಲ್ಸ್ ಥಿಯರಮ್. Okay, so here we have some problems on Rolle's theorem. Now we have to verify whether that Rolle's theorem is true or not to these problems. So this is the verification of Rolle's theorem. Verify Rolle's theorem for the function. Function ಕೊಟ್ಟಿದ್ದಾರೆ in the interval 2 4 ನಲ್ಲಿ ಈ ಫಂಕ್ಷನ್ Rolle's theorem ನ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡುತ್ತಾ? Okay. So Rolle's theorem ಈ ಫಂಕ್ಷನ್ ಸ್ಯಾಟಿಸ್ಫೈ ಮಾಡುತ್ತಾ ನೋಡಬೇಕು. ಓಕೆ, ಲೆಟ್ ಅಸ್ ಸಿ whether it is satisfying this Rolle's theorem or not. Okay, to verify the Rolle's theorem, first to take the function f of xy. So what is that function f of xy is? F of xy, function f of xy is given here. Okay, 1 minute, I'm taking the pen. Yes, the function f of xy is given here. So f of xy is the function f of x is the function. It is defined here. It is x square minus 6x plus 8. Function, it is clearly it is a polynomial. Clearly this function is a polynomial. All polynomials are continuous in the interval. Nodi, so to verify Rolle's theorem, we need to check three conditions. One is the continuity, second one is the differentiability, and third one is the condition f of a is equal to f of b. ಇಲ್ಲಿ a b ಅಂದರೆ 2 4 ಇದೆ. So we have to show that it is f of 2 is equal to f of 4. So first to take the function f of x is defined in the interval, is defined in the interval is defined in the interval 2 4. So you write that given function is a polynomial in x. Given function is a polynomial in x, is a polynomial in x. All polynomials are continuous functions. So it is a polynomial in x, therefore it is continuous. Therefore it is continuous function. Therefore it is continuous in the interval 2 4. This is the first condition. It satisfies the first condition. So next to write second condition. Second condition is what? Differentiability. So you just differentiate this function f dash of x is equal to The differentiation of f of x is f dash of x. F dash of x is equal to 2x minus 6. You just think that whether this f dash becomes infinity or it assumes indeterminate forms in the interval 2 4. ಓಪನ್ ಇಂಟರ್ವಲ್ 2 4 ಅಲ್ಲಿ ಯಾವ್ದಾದ್ರು ವ್ಯಾಲ್ಯೂನ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ಇನ್ಫಿನಿಟಿ ಬರುತ್ತಾ ಇಂಡಿಟರ್ಮಿನೆಂಟ್ ಫಾರ್ಮ್ ಬರುತ್ತಾ ನೋಡ್ಕೊಳ್ಳಿ. ಯಾಕೆಂದರೆ ಲೈಕ್ ಎಲ್ಲ ಪಾಯಿಂಟ್ಸಲ್ಲಿ ಡಿಫರೆನ್ಷಿಯಬಿಲಿಟಿ ಚೆಕ್ ಮಾಡೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. ಇಟ್ ಈಸ್ ಡಿಫಿಕಲ್ಟ್ ಟು ಚೆಕ್ ದ ಡಿಫರೆನ್ಷಿಯಬಿಲಿಟಿ ಅಟ್ ಆಲ್ ದ ಪಾಯಿಂಟ್ಸ್ ಇನ್ ಬಿಟ್ವೀನ್ 2 4. ಜಸ್ಟ್ ಯು ಥಿಂಕ್ ದಟ್ whether it assumes indeterminate forms or it value becomes infinity for any value in between 2 and 4. So okay, ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ when you are observing this, we know when you are observing this f dash of x, nowhere it is infinity or it assumes indeterminate form. Okay, so you write that f dash exits, f dash of x exits, it exits in the interval 2 4. That means it is differentiable in the interval 2 4. So next is the third condition. What is the third condition? F of a is equal to f of b. You take first that f of 2. F of 2 is equal to 2 square minus 6 into 2 plus 8, which is equal to 2 square is 4, 6 2s are 12, plus 8 is equal to 8 plus 4 is 12, 12 minus 12, 0. And you next you take that f of 4. F of 4 is 4 square minus 6 into 4 plus 8 is equal to 4 square is 16, 6 4s are 24 plus 8. 8 plus 16 is 24. 24 minus 24 gives 0. That is f of 2 is equal to, that is f of 2 is equal to f of 4. So that means f of x is the function satisfies all the three conditions of Rolle's theorem. ಮೂರು conditions Rolle's theorem do f of x satisfy ಮಾಡ್ತಾ ಇದೆ. So therefore f of x satisfies, write that therefore f of x satisfies all the conditions of Rolle's theorem. All the conditions of Rolle's theorem. Conditions of Rolle's theorem. So then, according to Rolle's theorem, therefore, there exists C belongs to 2 4. ಸೊ ರೋಲ್ಸ್ ಥಿಯರಮ್ ಪ್ರಕಾರ 2 4 ಮಧ್ಯದಲ್ಲಿ ಒಂದು ಪಾಯಿಂಟ್ನ ಎಕ್ಸಿಸ್ಟ್ ಮಾಡುತ್ತೆ ಇನ್ ಬಿಟ್ವೀನ್ 2 4. ಸೊ ಇಟ್ ಈಸ್ ಸಿ ಇಸ್ ದ ವ್ಯಾಲ್ಯೂ ಇನ್ ಬಿಟ್ವೀನ್ 2 4 ಸಚ್ ದ್ಯಾಟ್ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಇಸ್ ಈಕ್ವಲ್ ಟು 0. ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಮೀನ್ಸ್ ವಾಟ್ ಈಸ್ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್? ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ಅಂದರೆ ಏನಿದೆ? 2x minus 6 ಇದೆ. ಸೊ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಸಿ ಏನಾಗುತ್ತೆ ಅಂದರೆ ಇಟ್ ಈಸ್ 2c minus 6 is equal to 0. 2c is equal to 6, c is equal to 6 by 2 is equal to 3. 3 2 4 ಮಧ್ಯದಲ್ಲಿ ಇದೆಯಾ? ಸೊ ಇದೆ ಅಂದರೆ ರೋಲ್ಸ್ ಥಿಯರಮ್ ಸ್ಯಾಟಿಸ್ಫೈ ಆಗಿದೆ ಅಂತ. ಸೊ 3 is the value belongs to 2 4. Therefore Rolle's theorem is verified. Rolle's theorem is verified. That's all. This is the method of verifying the Rolle's theorem. First we need to check all the conditions of Rolle's theorem. So if it satisfies all the three conditions of Rolle's theorem, then we have to show that it exits one point in between AB. At that point differentiation of the function is 0. ಬೇಕಾದ್ರೆ ನೋಡಿ f dash of c 0 ಆಗುತ್ತೆ 3 ಕೊಟ್ಟಾಗ f dash of 3 is equal to 0 ಬರುತ್ತೆ. ಆ ಥರದ್ದು ಒಂದು ಪಾಯಿಂಟ್ ಡೆಫಿನೆಟ್ಲಿ ಎಕ್ಸಿಸ್ಟ್ ಆಗೇ ಆಗುತ್ತೆ ಅಂತ. One more problem on Rolle's theorem of this f of x is defined like this: x cube minus 4x. It is defined in the interval minus 2 to 2. It is the same procedure. First to take the function f of x. So let f of x is equal to, first to take f of x, let f of x is equal to, it is x cube minus 4x. It is defined in the interval -2 to 2. So like previous problem, this is also the function defined. This is also a polynomial. So since f of x is a polynomial in x, since f of x is a polynomial, it is a polynomial in x, therefore it is continuous. It is continuous. It is continuous in the interval -2 to 2. Second condition, differentiability. You take f dash of x directly. F dash of x is equal to 3x square. Differentiation of x cube is 3x square minus differentiation of 4x is 4. ಸೊ ನೋಡಿದ್ರೆ ಗೊತ್ತಾಗುತ್ತೆ ಯಾವ ಪಾಯಿಂಟನ್ನು -2 ಮಧ್ಯದಲ್ಲಿರೋ ಯಾವುದೇ ವ್ಯಾಲ್ಯೂಗೆ ಇದು ಇನ್ಫಿನಿಟಿ ಅಥವಾ ಇಂಡಿಟರ್ಮಿನೆಂಟ್ ಫಾರ್ಮ್ ಬರೋದಿಲ್ಲ. ಸೊ ಎಫ್ ಡ್ಯಾಶ್ ಆಫ್ ಎಕ್ಸ್ ಎಕ್ಸಿಟ್ಸ್ ಡೈರೆಕ್ಟ್ಲಿ ಯು ರೈಟ್ ದಟ್ ಇಟ್ ಎಕ್ಸಿಟ್ಸ್ ಇನ್ ದ ಇಂಟರ್ವಲ್ -2 to 2. Third condition is f of -2. F of -2 is equal to -2 whole cube minus 4 into -2. -2 whole cube is -8. Minus of minus plus 4 2s are 8. 8 minus 8 is 0. And next to take f of 2. F of 2 is equal to 2 cube minus 4 into 2 is equal to 2 cube is 8 minus 8 is equal to 0. So it satisfies third condition also. So that is f of -2 is equal to f of +2. So f of x is the function satisfies all three conditions of Rolle's theorem. So therefore f of x satisfies, write that f of x satisfies all the conditions of Rolle's theorem. All the conditions of Rolle's theorem. Accordingly, there exists C belongs to -2 to 2 such that f dash of c is equal to 0. What is f dash of c? F dash of c ಅಂದ್ರೆ ಏನು ಬರುತ್ತೆ ಇಲ್ಲಿ? It is 3c square minus 4 is equal to 0. So we need to find c value. C value find out ಮಾಡಿದ್ರೆ, so 3c square is equal to 4. C square is equal to 4 by 3. C is equal to plus or minus square root of 4 divided by 3. So C is equal to plus or minus 2 divided by root 3. So definitely I think 2 by root 3 is the value in between. So it is the value 1 point something like that. So definitely plus 1.1 or whatever it is. So that is both the values. So 2 by root 3 and minus 2 by root 3, both the values belongs to -2 to +2. So therefore, so these two are the values belongs to -2 to 2. Hence Rolle's theorem is verified. Rolle's theorem is verified. Okay, so like that, one more problem on the Rolle's theorem. So verify Rolle's theorem for the function f of x is equal to x cube minus 25. Yes, here also you follow the same procedure. First write f of x, given function f of x is x cube minus 25x. So it is defined in the interval -5 to 0. Since f of x is polynomial in x, since f of x is a polynomial It is a polynomial in X. Therefore, it is continuous. It is continuous. It is continuous in the interval -5 to 0. Second condition differentiability. So take f dash of x. F dash of x ತಗೊಂಡ್ರೆ differentiation of x cube is 3x square minus differentiation of 25x is 25. So nowhere it is infinity or indeterminate forms for the values between -5 to 0. So f dash of x exits directly ಬರ್ಬಿಡಿ exits in -5 to 0. ಯಾವುದಕ್ಕೂ ಇನ್ಫಿನಿಟಿ ಆಗಲ್ಲ, ಯಾವುದಕ್ಕೂ ಇಂಡಿಟರ್ಮಿನೆಂಟ್ ಫಾರಮ್ ಬರಲ್ಲ. ಸೊ -5 to 0 ಕೊಟ್ಟರೆ. ಸೊ ಥರ್ಡ್ ಕಂಡೀಷನ್ ಈಸ್ f of -5. f of -5 is -5 cube minus 25 into -5. So -5 cube is -125. Minus of minus plus 125 is 0. And f of 0 means, so x get 0 ಹಾಕಿದ್ರೆ it is 0 only. So that is f of -5 is equal to f of 0. So therefore f of x satisfies all the conditions of Rolle's theorem. All the conditions of Rolle's theorem. Therefore there exists a point C. Therefore there exists C belongs to -5 to 0 such that f dash of C is equal to 0. F dash of C is 3c square minus 25 is equal to 0. C square is equal to 25 by 3. C ಏನಾಗುತ್ತಂದ್ರೆ plus or minus square root of 25 by 3 is root 5 divided by root 3. So its value is 1 point something. Root 3 means it is 1 point something in the 5 na divide ಮಾಡಿದ್ರೆ it is value in between 5 divided by 1 or 5 divided by 2 is around 2.5 or 3 ಅದರ ಮಧ್ಯದಲ್ಲಿ ಬರುತ್ತೆ. So okay, so definitely that is the value. So negative ಮಾತ್ರ ಪಾಸಿಟಿವ್ ಇರೋದಿಲ್ಲ. So therefore C is equal to -5 by root 3. ಬೇಕಾದ್ರೆ ಕ್ಯಾಲ್ಕುಲೇಟರಲ್ಲಿ ಸಾಲ್ವ್ ಮಾಡಿ ನೋಡಿ. C is equal to -5 divided by root 3 is the value belongs to 0 minus 5, 0, 5. So you can check this. ಬೇಕಾದರೆ ಚೆಕ್ ಮಾಡ್ಬೋದು ನಾವು. So by taking the calculator. So here I don't have option. Yes. So that is the value 5 by root 3. 5 divided by square root of 3. Square root of, it is square root of 3. Yeah, I want to take 3 root. 5 divided by 3 root. Okay, 3 square root of 3 is the value 1.5 something. So what it gives? 2.88 ಬರುತ್ತೆ. So that is the value in between 0 and minus ಮಾತ್ರ. It's not positive value. So minus 2.88 is the value in between 0 and -5. -5 to 0. Sorry, you're right, it is -5 to 0. Okay. So like this you can check the verify the Rolle's theorem. So next class I wanted to solve some more problems on Rolle's theorem. So I want to end this